Welcome to your first video in Lesson 9.1. This chapter deals with polar coordinates, and I think you'll enjoy it. It's a different way of looking at the unit circle, and we're going to expand the unit circle. So I'd like to start just with what you know, in that, for example, if we go to a 60-degree angle right here, this triangle, if I make that 60 degrees, you know that this is the unit circle, so the radius is 1. You know that the cosine value, the x value here, is 1/2. The sine value is square root of 3 over 2. You know that that is cosine of 60 and the sine of 60. Now I want you to imagine taking this unit circle and expanding it, such that, look at this polar coordinate circle. This is the radius 1. Here's 60 degrees. So this point where my pencil is the same thing as this point. Now expand it to have a radius of 2, would be here, a radius of 3, a radius of 4, and so on. That's how we can achieve the polar coordinate, because it is the radius that you are coming out, that you're expanding, but still on the 60 degrees that you're familiar with, that we still have back on the unit circle. So when you give a polar coordinate, you're going to have a radius, and then you're going to have a theta value. Okay? Now before we plot all of these, I would like to give you some information. So I'd like to go through some vocabulary first and get this ironed out so that we can go back to the specifics here. Let's look at some vocabulary. The pole, with regards to a polar coordinate, is just the origin. And you would write that at 0 theta. That's the pole, the center, right there. The polar axis is the initial ray, usually horizontal, that comes out to the right. So from the pole out there is the polar axis. It's where we start all of our angles. The polar coordinates are coordinates that I mentioned in the form of r theta. R is a directed distance from the pole. We mentioned that that is the radius coming out from the pole. Theta is a directed distance from this polar axis. So again, we're going to think of that as 0, and we talked about coming up to 60 degrees. You can do any of the degrees, and if you notice, I have a lot more marked on this coordinate, this polar coordinate grid, than I do our normal unit circle. And that's very common. You will see more degrees here. I'd like you to point out, and have these also in your notes, it is much easier if you always graph the theta first. Much like what you're used to, the positive theta is going to go counterclockwise, the negative theta goes clockwise. But if you first graph the theta, figure out where you are on the circle, and then when you're plotting the radius, a positive radius is on the terminal side. You're going to go forward from the pole out to that radius. If it's a negative radius, you're going to essentially go backwards. You're going to go in the opposite direction of the terminal side at that theta. This is a circle, and you can spin around just like we did before, and you can have many, many, many coordinates at each point. And therefore, you're either going to add multiples of 360 or multiples of 2 pi, depending upon whether you're in degrees or radians. And your radius will always be either positive or negative, depending upon where you are on the circle. Now, what I would like to do is to practice plotting some points so that you can see how to read the polar grid. Okay, for example, point T is at 560. So the first thing we're going to do is we are going to graph, find 60 degrees, it's right here, and then we're going to go out a radius of 5. 1, 2, 3, 4, 5. We're there. So that is point T. Now let's do R. We're going to go to pi over 2, which is here at 90 degrees. We're going to have a radius of 3. 1, 2, 3. That's going to be R. Okay. I. We're going to go to 150. Always do the theta first. 150 is right here. And we're going to come out to radius 4. 1, 2, 3, 4. So far so good, right? It's not that bad. Let's try this one. Pi over 4, again, pi 45 degrees right here, but my radius is negative 2. So if it was positive 2, I would come out here, but it's negative 2, so I go backwards, and I'm right here for point A. Okay, that's important. You went backwards. Here, negative 60 degrees. You know that that goes in a clockwise direction if it's negative. So we're going to be negative 60 degrees. We're going to be right here at what is marked the 300, and it's a positive 5. So we're going to come out this direction 5 rings. That would be right here. There is point N. Point G, negative 5 pi over 6. Well, positive 5 pi over 6 is here in quadrant 2. So negative 5 pi would be over here in quadrant 3, right? And it's a radius of 4. So we're going to come out 4 rings. Right there, that is point G. Point L, pi over 6, you know that to be 30 degrees, and it's a negative 4. So we're going to go here, back 4. 1, 2, 3, 4. That's L. So I want you to notice that both G and L are the exact same point. They look different. Every part of it is different, but they are the same spot on the circle. Here, negative 3 pi over 4. So we're, that positive 3 pi fourths would be over here, right? This is negative 3 pi fourths, so I'm in quadrant 3 at 225, and it's negative 2. So I'm going to back up, and I'm right here on that 45 line. That is letter E. All right, S. 420. Oh, wait a minute. That's bigger than 360, isn't it? So we need to do 420 minus 360. Okay, that is at 60 degrees. So if we go all the way around and then we come back up here to 60 degrees, that is right there where we labeled T. That's also S. So S and T are the exact same point. And we're going to try to label, give multiple names for each point. I would like to practice doing that. So we need to set that up for the next page. I will be right back. Okay, so what I'd like you to look at is right here. We're going to fill in this chart. We're going to find the equivalent polar coordinates. And when we do, let me cover up some of this other so that you don't see it. It may be helpful if you have the circle handy. So I'm going to pull up the circle that we just used on the other section so that you can see that. Let me see if I can get that on there. There we go. All right, so the first point, it says right here, is give a polar point if the theta is less than 0. That means if it's less than 0, that means that you're going in the negative direction, right? So the radius is going to still be 3, but we want to go around. If you're here, let's find out where we are. 120. We're here, and you're at 3. So it may help if we make a little pencil mark. 1, 2, 3. We're right here. Now I want another name for that. Well, if I go in the negative direction, if theta is less than 0, if I go in the negative direction here, that would be 240. You see, that would be negative 240. So that's what I'm going to put right there. For this theta still has a positive 3, but instead of coming around here to 120, I've gone around to negative 240. Okay? Now let's try if r is less than 0. So now I want the negative r, which means if I'm still wanting that point right there, I have to be over here and then send it backwards over here. So I want to be over here at 300 and then send it back 3. So I have a negative 3 if I was at 300. I came all the way around to 300 and then went back 3. That would be that point. Okay, now I want to have a negative theta and a negative r, which means I still need to be here, but I'm going to come negative to 300. Well, that would be a negative 60, right? So I would have the negative 3, but I would come to negative 60 degrees, which would be here at the 300, and then kick me backwards to the negative 3. Now I want you to add 360, because if we're at theta and theta is greater than 2 pi, you can go all the way around and you're going to have 360 plus that 120. Well, that makes 480. So here I would still have the 3 and then be at 480. Okay? So I'm going to stop the video here. We're going to come back and finish the rest of this and do a little bit more in the second video. If you'd like to, you can pause right now and you can fill in the other 2 rows, and then we'll see how you did. See you in a bit.